Hello everyone, welcome to Overseas Volunteers for Better India Vedic Math Introduction by Senior Teacher Bachubai. He is visiting. We will start with a short presentation of OVBI and then Bachubai can do the Vedic Math. Anand, do you have any cell phone which is attached? So Overseas Volunteers for Better India is in many countries now. It is to build a more culturally rooted and economically advanced India. We have thousands of NRIs who are helping out with various projects which are in India and also in the NRI countries. Also, we want to reconnect NRIs to the roots and heritage, and this event is in that direction. We want to improve the pride for India. It was launched by Sri Sri a few years ago so that people can connect better with spirituality, Indian food, IT, tourism. Thousands of projects have been done in voter awareness. Rural and social projects have been done by Volunteers for Better India. So OVBI is the overseas arm for VBI. Like this is rainwater harvesting. We do it in less money than the government. A lot of women empowerment projects are done. And then in various cities, whatever is the need of the city, we work with that, whether it's in Mumbai, Uttarakhand floods. And this was done, President Abdul Kalam gave us an award for the mobile app, as you can see. This was very nicely received, and a lot of IT people from US helped out in various companies. This is an education initiative for VBI, where you learn about India's history and culture and lots of other special topics like Vedic mathematics. And we have our website, knowourindia.org, that you can visit. And here you see volunteers from across the US in various events, canvassing and spreading awareness. And we have given a forum to a lot of Indian leaders, a lot of cultural events. This is the School of Good Governance that we have started. And there's a women's wing also now. There are a lot of other projects like People Flew to India to Vote and Lighting Lamps and Adopt a Village and a lot of AI related projects. So we want people to get together and have good, big ideas for a better India. And we've helped out in government events also. And we have at-risk kids also helping to get educated. So how we can help, we can become a volunteer, we can enroll on overseasvbi.org. From there, all the other projects, details, and fundraising information is there. You can network with NRIs in your area and then you can help out. So with that, I will, with a brief introduction, we will take it over to Bachubai, who will tell us about Vedic mathematics. And Anand is one of the organizers here today. Over to you, Anand.
Thank you, Mehul. As you were describing, Bachubai has a great wealth of understanding and knowledge, and also about philosophy, how Vedic mathematics thinking is slightly different from the traditional one. And I had privilege to drive him here, and during that, I got to learn lots of interesting ideas which we are implementing in different parts of mathematics. So you start with a simple idea, and then you can repeat to the more complicated ideas, and also across the different domain of mathematics. So there is no real boundary. And what Bachubai is trying to do is to make it start from the basic, but then take it across. Learn idea how to apply rather than just learning methods. And with that, I hope that Bachubai will describe some of the ideas like how you can use in trigonometry or even algebra and other places. And on to Bachubai now.
Okay, thank you. Yeah, friends. Today we are to talk about Vedic mathematics. What is Vedic mathematics? How it works in different fields of mathematics? How it works? We will see now. What happened in fact? How the question is how Vedic mathematics came in action. That's the idea. And किया. The Krishna Tesarji Maharaj, the Hindu saint, the Sankaracharya of Jagannath Puri, he was a scholar. He was quite prompt in mathematics. When he appeared in his graduation, he was a topper in all the subjects. And his interest in mathematics, even after being Sankaracharya, didn't left it. He cannot leave it now, I think. And so what happened is, he thought of making the mathematics popular among the people. And he tried to use small verses. So he had constructed 16 verses and 16 the subverses, that is the sutra and up-sutra. And he tried, according to me, a great use of algebra in arithmetic and in different fields of mathematics. He had been to USA with his followers. He tried all of these verses, the use of it, and the people were mad behind him. After returning to India, his followers requested him that what you showed in USA, why don't you put it in the people of India? And he tried to write down a book, a small book published by one of the publishers in India, Motilal Banardas. What happened is in different chapters he had noted that we shall discuss it onward. But unluckily, his health did not cooperate, and he finished some chapters left for the students, for the followers. According to me, Vedic mathematics is an idea of thinking how to represent a subject in, I think, an amusing or pleasuring way, and we shall discuss some of them, some topics. I shall try to take you through arithmetic, some algebra, some geometry and trigonometry, and try to discuss the ideas what he tried to put up. Many more things are there in Vedic mathematics worth studying, and I shall show you the way in which Vedic method works. I think let us start from the beginning. Throughout the studies of Vedic mathematics, I have observed that wherever we shall use the word base, base is 10 power n, where n is a natural number, positive integer. And so, whenever we say base, that is the power of 10. So, it may be 10, it may be 100, it may be 1000, and so on. So, that's the base. When we say you are using of sub-base, it is a k into power of 10 raised to n, where k is greater than 0 and k is an integer. Main thing is this, and throughout the whole discussion of arithmetic in Vedic mathematics, I have seen that he had used these base and sub-base, and concerning this, you can calculate many things so speedily. Let us see now. In Vedic mathematics, we use one is nikhil. So use of nikhil really many times used, and Swamiji gave a fine verse, Nikhilam Nata Charmam Darshata. In English it is all from 9 and last from 10. So if x is a number, if you add y, you are getting 10 power n. Y is to be considered as nikhil. So means to get nikhil of x, you need to subtract it from 10 power n. Let us see how it works. Suppose 7 is there. I'd use one word, and that is nikhilish. X plus nikhil of x, that is to be nikhilish of x. Very easily I can say that if a number is given to you, replace all of its digits by 0 and place 1 before it. For example, 7 is there, 0 and 1. So we are replacing 7 by 0, putting 1. This is nikhilish for 7. So what number to be added to 7 to get 10? That is 3. 3 is a nikhil of x. Now see here. Not only that, but you can say 0, 3 is also nikhil with reference to 10 is to 2. If you consider this, because if you consider these as 7 and 0, 7, no doubt 7 is an integer having one digit. It can be represented by 0, 7. So 0, 3 will be also its nikhil. Same way, if you consider 0, 0, 7, that will be 0, 0, 3. With considering the base, you can find different nikhils of a given number. And throughout Vedic mathematics, nikhil will be used in many places. So, how this idea comes that all from 9 and last from 10, I shall take you, suppose 50438 is a given number. Its nikhilish will be 0, 0, 0, 0, 0 and 1. Now if you want to subtract these numbers from the nikhilish, you are getting nikhil. And so what will happen? We know, we take care from here, there is 10, 9, 9, 9, 9 and last. And now subtract this one. You can see it is 2, 6, 5, 9 and 4. So this is nikhil of 50438. What happens is, each number is subtracted from 9. So all from 9.
Sorry about that. Keep going. Connection. Can you see?
No, because
Yeah, we can see. We can.
Sorry.
No, we
sorry
can,
about that.
you can see that. You can increase the height of the laptop through books, but otherwise it's very clear. Go ahead.
Okay. That's all. Okay. So this was the idea of Swamiji, that to subtract each digit from 9 in last. Here, last means last non-zero. I should remember. And yeah, subtracting it. So basically, see, nice use of this one is to subtract a number from a nickelish. It becomes easy. For example, see here. 58000000 minus 3875432. In spite of subtraction from right side, we can subtract from left. You can say if I take 1 from here, it becomes 7, and this will be nickelish. And so I can say this is 54. And now 819, 729, 549, 459, 369, and 810. So subtraction becomes very easy. In spite of going from right to left, we are going to left to right. And it is the main benefit of this nickel. It is a very simple use of nickel. Okay. This is one thing. Let us go to the next thing also. And I shall try to develop. And that is digital root. See. The second one is digital root. Digital root has the two different kinds. One is additive and another is subtractive. And additive means it is added together. So heading or digits into one digit is known as additive digital root. And here is subtraction of digits. Alternative digits, you can say. You can say it is alternative digit sums. So whenever we need of this one, we shall discuss it in detail. Okay. In fact, this digital root is used many places. I only try to draw your attention, and I shall show you how it works. This, I think it is the remainder dividing on 9, dividing by 9, and this is remainder dividing by 11. So, for confirmation of the answers of the different actions of addition, subtraction, multiplication, this products, division, this becomes useful, but I shall not try to discuss more thing about it, but this will be useful. But see, only 1 or 2 illustrations will be sufficient. For example, 543 2. Now see here, 5 and 4 is 9, and 3, 12 to 14, 7, 21 to 23. So this 23 goes to 5. So 5 is the digital root. This is ADR, additive digital root. You take 2 to the 4, 7, 3, 10 and 5, 15, add 11, so that will be 9. This is the subtractive digital root. If we divide this by 11, you have to get 9. Same way, if you divide by 9, you are getting 5. So ADR and SDR will be used many times to find out whether your answer is true or not. But I think it is not advisable to discuss this more about this, because in fact this is the, I think, a nice process to select the proper alternative from given some 4 or 5 alternatives. So you can directly get it without carrying out the different reactions. I think you can find out, but I think you don't need it. Main thing. Then next is, see, I shall take you to the next one, and that is the Viunculam. In fact, it is a negative number. In fact, I say negative digits. This is a great boon according to me. Negative digit used. So, Swamiji say that in Vedic mathematics, you don't need to use a digit greater than 5 at all. If you know this use of negative digit, that is vinculum. For example, it is, suppose it is 17, it is 20 minus 3, so you can say 20 plus 3 bar is 231. Not only that, I can say 5384. You can see this one. So you can say it is 5, 40 minus 2, 4, and that will be 542 by 4. See here. This is the specific use of a negative number, or we can say negative digit. You can place here, instead of 38, you can put 42 bar, and obviously now in this digit, there is, in this number, there is no digit greater than 5 at all. And you can change it out. There is a way of finding out, or I think adopting this negative digit as vinculum. I shall show you a simple way. If you people know about the negative numbers, I shall take you to 500032 minus 287618. I shall show you the different methods. One method we know, you take care from here, 10, this will be 9, this will be 9, this will be 9. Or you can see instead of this, you can 10. You can take care from here. We are using this. This is a method we are using. 12 minus 8 is 4. This is 1. This is 4. This is 2. This is 1. It's 7. If we use the vinculum way, see, I said so. Instead of this, my suggestion is See now, if you want to subtract 1, 0, 0, 0, 3, 2 minus 2, 8, 7, 6, 1, 8. Now see here, the way in which what I want to put is this one. You put a dot here. If the number is not possible to be subtracted, use nickel. Nickel of 8 is 2, add it here 4. So we make a rule that subtract a number, add its nickel. And now add its nickelage. Subtract nickelage. So the way, see, to say you want to subtract a number, so add nickel and subtract nickelage. So what we are putting is, this is nickelage, 10, 8 is 2, 2 plus 2 is 4. 3 minus 1 is 1, so it is 0. Now see here, you want to subtract 6, nickel is 4, subtract nickelage. This one, here we have to subtract. Do remember, the way is how we are going. You are not able to subtract this 7. Okay, so its nickel is 3, subtract nickel is 3 minus 1 is 2. Same way, it is 2 minus 1 is 1. Subtract nickel is 5 minus 1 is 3, minus 2 is 1. Now let us check whether the subtraction is true. 8 and 4, 12, 1. So here it should be, it was 1, so it should be 1. Because see, 3 minus 1, 2 minus 1 was 1. So now 8, 4, 12, 2 and 1, 3, 10, 1, 3, 7, 10, 1, 2, 8, 10, 1, 2. So should remember, here is 4. So when you are committing mistake, you can very easily understand. It's simple. Should remember. Now you can check it out. 8, 4, 12, 3, 10, 1, 10, 1, 10, 1, 3, 8, 2, 5. So now it's straight. So the another way is see how the vinculum goes on. You can say. You can say this is a 5, 0, 0, 0, 3, 2 minus 2, 8, 7, 6, 1, 8. 2 minus 8 is 6 bar. 3 minus 1 is 2. This 6 bar, this 7 bar, this 8 bar, this 3. The bar is there, see now. So this is 20 minus 6 is 14. Do remember, we are taking 1 from here. So 10 minus 6 is 4, nickel. Same way here, we take 1. So it will be 2. 1000 minus 876, so it is nickel 1, 2, and 4. So answer is there. And 3 different ways of subtraction. This become very easy in spite of this. See, we don't need to worry much, and you can directly apply the winkle. Okay. Okay, now let us go to multiplication. For multiplication, general method is generally known as crisscross method. In this method, in fact, the name is vertically and crosswise products. In Sanskrit, it's named as Urdhva Dirgham, but you don't need it, so I think better is that one. Question is, how this is used? How vertically and crosswise method? What is the method? And that should understand. Well, I take the different circumstances in which, suppose 5 and 4 are there. One digit above another digit, then it is 5 into 4, it is 20. Well, 3, 2 and 5, 4, so 2 digits below 2 digits. These goes here and these goes here. So it is 5 into 4, 5 into 2 plus 3 into 4, 10 plus 12, 22. If there are 3 digits, 2, 1, 3, and 5, 4, 2, you should understand. Last will go to last. That is 2 into 2 plus 5 into 3. This is plus 2 into 4. 4, 15, 23.
You're not multiplying right now. You're not multiplying the numbers.
No.
You are just giving the
Only
cross
these.
products.
So we try to understand what is the crisscross product. Do you follow me? This is not a product. This is crisscross product. That should be understood. And we shall use it how the crisscross product will be used for product. For multiplication, we shall use it. At this stage only we are trying to understand. So base 2 is, see now, I shall remove now and give the fourth position. Or you can take any position, no problem. Suppose there are 2, 3, 4, 1, 0, 7. Suppose there are 6. And now 3, 4, 1, 5, 2, 3. Try to understand it. So we can think in this direction. So these are rectangular form. So this is diagonal, and so you can say 3 into 7 plus 2 into 3. From the remaining, you can now frame another rectangle. Now you can go 3 to 2, so plus 3 into 2, and this is 4 into 0 plus 4 into 0. For remaining, you can go These 2 here. So plus 4 into 5 plus 1 into 1. Last to last. Now product will be 21 plus 6 plus 6 plus 0 plus 20 plus 1. It is 54. So we can make a rule. Take the last digit of 1 to the last is another 1 on the next day. Then last to last remains the last to last, last to last. And remaining is to this. So try to multiply the last digit of one end to last to another end. Get product, have the addition, that is known as a crisscross product. Okay. Now we shall see how this can be used. So we should try to study this way. Suppose you want 34, 23. You start from unit, it is 4 into 3, the first step. Second one increase more, 3, 4, 2, 3. Then increasing over, decrease this, getting 3. We start from the unit digit, 4 below 3. 3 below 4, 4 above it. Then increase 1. And then, between this is 4 into 3, that will be 12. This will be cross product. This is 3 into 3 plus 2 into 4. That is 9 plus 8, 17. And this will be 3 into 2, 6. This is a math, you remember. This is a unit. It is tens, with hundreds. And so this is 2. One will go here 8. One will go here 7. That's the answer. Well, I should take you. These are 4 and 3 is 7. 3 to 2 is 5. ADR. Multiply them, you are getting 35. That will give you 8. 3 plus 5. Additive digital root. And you can get here also 2, 8, 10 and 7, 17. And that will be 8. So that means that the product is true. Your multiplier work is true. You can check by ADR. Well, I take you to another one also. See now. I repeat it and show you direct way. 72 into 24, you want to multiply. Put 2 and 4. Vertical product will 8. Then we put 7 and 2. We increase one more. 4, 7, 28 and 4. 32, carry 3. We put carry. Now increasing over. Remove this, we are getting 40, 17 answer. See the way how this crisscross product helps you to multiply directly. So even if you remember this one, you can remove this also. If you don't write it, that will do. So simple way, 1 to 4, 7 to 4, and then 7 to 2. Same way, if you understand it properly, then it becomes very easy. Suppose it is 4 to 3 into 5 and 4. We start this one. 3, 4. Vertical product, we can put carry on the right. You put 2 and 1, there is cross product, 8, 3, 11, and 1. 12, carry 1. This one is over. Now we take 4, 5. Crisscross product is 16, is 15, 31, and 2, 33, and 1, 34, carry 3. Increase of the disease on the left is over. This we are getting 4, 2, 5, 1. So you can say it is 4. This is 10, 14, and 3. 17, carry 1. Remove one more digit is 20 and 121. So you don't need to multiply. See, we have in our method we multiply by 4, put across, then multiply by 1, put across, multiply by 5, and 1 is just putting 4 steps together. Here only one step. Direct method you can find out the product. See how Vedic mathematics helps it. It may be even any mark. You can say 1 digit, 2 digit, 3 digit, 4 digit, and so on. You go on multiplying the vertically crosswise. You get it. They applying the crisscross. You can multiply any digit number with any digit number. Maybe suppose there are this way. Then what to do? You will have the question. Suppose it is 3, 4, 2. Say 81. You put 1, 0. Apply the method. No problem. So you put in 1, 0. You will have 3 digits to 3 digits. Method can you apply? You may be 4 digits. Same way. 1, 2, 3, 4. It is 1, 3, 2, and so on. I think you have followed me. Well. You will understand what you are working.
So, as I understand, your crisscross product, basically, first you define everything in terms of crisscross product. So, and then every crisscross product is easy to calculate in mind.
Yeah.
So, any big multiplication, you break down into crisscross products.
Okay.
And then you go from, from unit digit to multiple.
Very good.
Yeah, that's how.
3, 1, 0, 4, 3, suppose.
Right.
And 2, 0, 5, 1, 4. Suppose these are big number.
Right.
Let us see how can we apply it.
So the idea is to break down into crisscross, which can be done in head.
Sure.
Okay.
You can start 3, 4. Vertical product 12. Carry 1. Put 4, 1. There is 16. 3, 19. And 1. 20. Carry 2. 0, 5. Now we are followed last to last is 0. 15. And 4, 19. And 2. 21. Carry will be 2. You can put up one more. 1, 0. 4, 0, 0, 20, 24, and 2, 26, carry 2. Take 1, 3, 2. Last to last is 12, 18, 19, 0 and 0, and 2, 21, carry 2. Now see, we remove one more.
Right.
So it is 3, 11, 16, and 2, 18, carry 1, do one more, 15, 0, 0, 16, carry 1, remove 1, 0, 2 and 1, 3, remove 1. easy to calculate. And it was experienced that even it may be a big number of 8 digit and 8 digit are having happened practice, you can take it within 2 minutes also. But see, if you understand the method, that's all. You need a practice, no doubt.
Right.
In mathematics, practice is essential, and without practice, man can never succeed. Well, so this is all about this one. Now, there are some interesting methods in some specific positions. For example, somebody sometimes say 6, 7, 8, 9, 8, 7, 4, 3, 2, 4 into it may be big number. So one number is made up of 9. Another having same equal numbers of digits. You can write down 6, 7, 8, 9, 8, 7, 4, 3. Degrees last for 1. And now subtract each digit from 9, getting 3, 2, 1, 0, 1, 2, 5, 6, 7, and 6. That's answer. This is known as by one less than previous. What you need is only subtract 1 from here, subtract each digit from 9. Only the thing is, it may be the people show that is a magic, it is nothing like magic. In fact, question is how to, let us start with the beginning and understand the method. 9, 7, decrease 1, we are getting 6 and 3. So this is the previous one. Subtract what you are getting 6, subtract 9. Same way, 9 and into 34, 33, 66 answer. Then 542 into 999. Decrease 1, you are getting 541. Subtract it digit from 9, you are getting 1. And there may be bigger number, no problem.
Right. So should we get build upon arithmetic and go to trigonometry or geometry? Or
Yeah, we shall. Now we are going. So, I'm coming here, no problem. One method I want to show you that is also see how it is. Suppose you want 92 into 96. From arithmetic we shall go to algebra and then to geometry also, no doubt.
okay.
Yeah. So now here the base, use of base, 100 will use the base. Both of us are small, -8 is -4. You can say it is 0.8 and 0.4. Subtract 1 here, getting 88. Now multiply these two, you are getting 32. You can subtract this from this or this from this, no problem. No difference in there. You can see 92, 4, 88, 96 minus 88, whatever you like. And then product this one. So once you understand it, this can go orally done. 92, 96, they are both smaller than 100. So subtract this one, you are getting 4. Subtract 4 from here, 88. And these two, 8 to 32. So once you understand the method, so to be easy. Question is now, suppose it is 292 into 296. See now, we base 300. At the beginning I said the base is power of 10. This sub-base, multiple of this power. So you can say it is minus 8, 008, minus 004. So you can take it as 288. Do you remember? This is 3 into 100. This by 3, nothing more. And then is 032. I'm sorry, this is wrong. But it's 20. And so, I'm sorry. So once you understand the method, it's not difficult. If you go 3000, maybe you should remember as when you zeros and the bases, those bank digits should be adjusted. And if it is more, the remaining part will be added on the left. Okay, that's all. So this is use of the base. In Vedic mathematics, in Sanskrit it is said on the Rupiana, you can say they proportionately. Proportion of the base and sub base to multiply before we adjust the product. Okay, well, I think this is sufficient for drawing your attention toward the product in the Vedic mathematics. Let us go to the square one. Generally, we are habituated to multiply. Suppose you want the 92 square, you multiply 92 by 92. So you 4, 184, cross this one, this is 6, 4, 8. Much more work is to be done. In spite of that, our max of base will be applied there. So you can say, you want to find out the square of 92, have the base 100 nearby. The difference is 8, apply 84, it is 8 square. So it is 84, 64, and that's it. You don't need to multiply. See now, for example, here it is 296 square. So here also proportional will be there. So we can select 300 as a base, and it is 3 times 100. It is 4 less, you can say 292. And method is 4 square, but you should remember that base is 3 times, so multiply by 3. And so you can say there are 2 zeros, 60 answer. So you can see you don't need to multiply 293 to 296. What becomes easy and easily you can find out the square. Well, so this is known as the use of the base. You should remember. In fact, and in Sanskrit it is known as Yavaduna. As much less, you have to subtract it. As much more, don't necessarily that it should be only plus. For example, I can take you to 412 square. You can take 400, and 4 into 100, 12 more, so increase it to 424, and 12 square to be adjusted, and before that you have to multiply by 4. So you can see it is 16 and 96 This will be 144. Should remember, 2 zeros are there, 2 numbers to be adjusted, and the third number will be added on the left. We are getting 1697 44. You can see if you know the method to find the square of a number of 3 digits, not only 3, maybe 4 digits, also no problem. But the method is this. Base is there, should remember. Select the base nearby to it. Well, even question will be there. Suppose difference is big or not. Then I can show. I should like to draw your attention towards the duplex. We need more time, but I shall try to explain you and how you do, and I shall show how one himself can put up the square directly. So I can say that I should try to explain you in short without taking more time. So I think there is a double product of equidistant digits. I put up more body sum of double product equidistant digits. The question is, if one number equidistant on both sides, so a single number will be there. If single digit, no pair, then it's square to be added. There are two things. I shall try to give some illustrations.
Yes.
Okay.
Yeah, one illustration.
Yeah?
One illustration. Please.
Yeah, one will be sufficient. I know. See now. You think if you know the duplex, then it's simple. The number is duplex. 3, 9. I don't understand. 24, that is 2 into 4 into double, 16. 3, 5, 2, 2 into 3 into 2, plus 5 square. 12 plus 25, 37. And now you can take it. 5, 4, 1, 4, 6. That is 30. 16, 46. 7, 92. And 1, 23. So what you need is to go on pairing, make a pattern, go on adding. Pairing is over, make it double. So what you need is double, that 5 into 6 plus 4 into 4 plus 1 square. So what remains unpaired. And so that is what's that. Well,
Yeah, hello. Your handwriting has become lighter, and I think your Wi-Fi may have become slower. So everything is very hazy out there.
Can you write something?
yeah. Okay. Now you want 32 square.
Okay, I think I know what.
The height, you can say,
Bachubhai, if you can wait a minute, we are not able to see properly.
Excuse me?
If you can wait 1 minute, we can fix the Wi-Fi. So because we cannot see clearly on the whiteboard.
Oh, okay.
So while they are fixing the Wi-Fi, we will show our website here.
Oh. Wait a minute.
So this is our overseasvbia.org website, where we have, as you can see, we have a lot of thousands of members and many volunteers in several countries. And this is how we make an impact in various projects. There are many categories of projects, so we hope maybe like out here that you can align yourself with many of our projects. And then if you want to donate, you can come here. And we have a lot of projects here that you can donate. And then so this is a project called Know India. And then you can actually read more about it. And this is our website for Know India. So there are a lot of topics about media, geopolitics, current affairs, and a lot of things about the real history and things about Sanskrit, spirituality, Ayurveda that we can know. So there are a lot of these videos out here that you can access, and you can actually read all the testimonials here. So with that, this is something new we have started for the Indian Martyrs Fund. This one, and then also one of the other initiatives is the India Water Project, where we are rejuvenating dry rivers with a lot of cool technology. I think they're still setting up your Wi-Fi. It is still a little unclear. So while they are fixing it, we can. This was. This was a presentation that we showed earlier. In case some of you guys missed it, these are the mission and some of the things to connect with India better. This is how it was launched in some of our projects here. It's in thousands of villages, 200K volunteers. The river project is gaining a lot of importance right now because we need to preserve the water and make sure people have access to good, clean water for their household purposes. And this is a lot of crisis work also. We help out. And those who are very technologically bent, we have technology projects also for those folks who want to help out. This is a Know India initiative. This is a very unique and interesting initiative about teaching students how for good governance. So when they go into government jobs, they are now better educated about how to lead the people. Surajya is that project. So, if you like to start your own project also, you can suggest. But there are many other ideas that we can join with. And as Mahatma Gandhi said, be the change that you wish to see. So we are all instruments of change. So hope you guys can take advantage of a lot of the opportunities that we have. And so now we are going to go back to